Hello everyone, welcome to my DC Global. This is the second part of the mathematics in which we'll include the quick revision for the probability and distribution. Here first one is event. Here it is the outcome of an experiment is called event. Then mutually exclusive events. Here it is also known as disjoint events. Here two events are called mutually exclusive if the occurrence of one excludes the occurrence of the others. For examples, both can't occur simultaneously. Here A and B is equals to 5, then P of A and B is equals to 0. Then after equally likely events, if one of the events cannot happen in preference to other, then such events are said to be equally likely events. Then odds in favor of an event is equals to m by n, where m is equals to number of ways favorable to A and n is equals to number of ways not favorable to A. Then after odds against the event is equals to n by m. Then after probability, P of A is equals to m by n, which is equals to number of favorable ways divided by total number of ways. So you can say that P of A plus P of A dash is equals to 1. Then after important points are here, P of A or B is equals to probability of happening of at least one event of A and B. Then after P of A and B is equals to probability of happening of both events A and B. Then after if the events are certain to happen, then probability is unity. Then if the events are impossible to happen, then the probability is 0. Then addition law of probability. Here first one is for every events A and B and C not mutually exclusive, then P of A or B or C is equals to P of A plus P of B plus P of C minus P of A and B minus P of B and C minus P of C and A plus P of A and B and C. Then for the event A, B and C which are mutually exclusive, then P of A or B or C is equals to P of A plus P of B plus P of C. Then next one is independent events. Here two events are said to be independent if the occurrence of one does not affect the occurrence of the other. If P of A and B is equals to P of A, P of B, then these two events are known as independent events. The next one is conditional probability. If A and B are the dependent events, then P of B by A denotes the probability of the occurrence of B when A has already occurred. This is known as the conditional probability. So you can say that P of B by A is equals to P of A and B divided by P of A. This equation is very useful in the examination. Then here next one is for independent events A and B, P of B by A is equals to P of B, because as you all know, for independent events P of A into B is equals to P of A into P of B. Then after theorem of combined probability, if the probability of an event A happening as a result of a trial is P of A, then probability of an event B happening as a result of trial after A has happened is P of B by A, then the probability of both the events A and B happening is P of A into B is equals to P of A into P of B by A, where P of A is not equals to 0. Similarly, P of A into B is equals to P of B into P of A by B, where P of B is not equals to 0. So basically these two results you have to remember for the examination. This is also known as the multiplication theorem. Then for the independent events A and B, P of B by A is equals to P of B and P of A by B is equals to P of A. Hence P of A into B is equals to P of A into P of B. This is the proof for the above results for the independent events. Then after important points are there. If P1 and P2 are the probabilities of two independent events, then First one is P1 into 1 minus P2 is equals to probability of first event happens and the second fails. For example, only first happens. Then 1 minus P1 into 1 minus P2 is equals to probability of both events fails. Then third one is 1 minus in bracket 1 minus P1 into 1 minus P2. Then it is probability of at least one event occur. And the last one is P1 into P2. It represents the probability of both events. Then here it is one of the most important topic from the probability portion, which is known as Bayes theorem. As you all know from this theorem, there may be one or two questions every year. So let's start the theorem. An event A corresponds to a number of exhaustive events b1, b2 up to bn. Then if p of bi and p of a by bi are given, then p of bi upon a is equals to p of bi into p of a by bi divided by sigma p of bi into p of a by bi. So this is the equation for the Bayes theorem. Here this is also known as the theorem of inverse probability. So by looking towards the equation, it looks like something critical, but once you are calculating some example based on this theorem, then it will be very easier for you to calculate the examples in the examination. Now the next one is the random variable. Real variable associated with the outcome of a random experiment is called a random variable. Now the next topic is distribution. Here there are 4 to 5 distribution functions are there. First one is probability density function, PDF, or also you can say that probability mass function. Here the set of values x with their probabilities pi constitute a probability distribution or probability density function of the variable x. If f of x is the PDF, then f of x of k is equals to p of x is equals to xk. Then PDF has the following properties. First one is probability density function is always positive, f of x greater than or equal to 0. Then integration minus infinite to infinite f of x dx is equals to 1 for the continuous, and sigma I is equals to 1 to and f of xi is equals to 1 for the discrete function. Then the next function is discrete cumulative distribution function or distribution function. So here it is also known as CDF. Here if f of x is equals to p of x less than or equal to x, which is equals to integration minus infinite to x f of x dx, then f of x is defined as the cumulative distribution function or simply the distribution function of the continuous variable. Then CDF has the following properties. First one is integration d of f of x into x divided by dx is equals to f of x dash into x, which is equals to f of x greater than or equal to 0. Then second one is 1 greater than or equal to f of x is greater than or equal to 0. Then the third one is if x2 greater than x1, then fx x2 greater than fx x1. This is the condition for the CDF is monotone, or you can say that non-decreasing function. Then the next one is f of x of minus infinite is equals to 0 and fx of infinite is equals to 1. Then p of a less than or equal to x less than or equal to b is equals to integration a to b f of x dx is equals to integration minus infinite to b fx dx minus integration minus infinite to a f of x dx is equals to fxb minus fxa. So these are the some important notes you have to remember. Then the next topic is expectation e of x. Here e of x is equals to sigma I is equals to 1 to n xi into f of xi. This is for discrete case. Then second one is e of x is equals to integration minus infinite to infinite xi into f of xi dx. This is for the continuous case. Then there are some properties of the expectation. E of constant is equals to constant. Then e of c into x is equals to c into e of x, where c is equals to constant. then e of ax plus by is equals to a into e of x plus b into e of y, where a and b are constants. Then fourth one is e of xy is equals to e of x into e of y by x is equals to e of y into e of x by y. Here e of xy is not equals to e of x into e of y in general, but e of xy is equals to e of x into e of y if x and y are independent. So these four properties are most important for the examination, because every year there may be one question from these properties of expectation and the variance. Here the next point is variance. It is denoted by var of x. So in general, the equation of var of x is most useful in the examination. It is denoted by var of x is equals to e of x square minus e of x whole square. Then here there are some important properties for the variance. First one is variance of constant is equals to 0. Then second one is variance of c of x is equals to c square into var of x minus variance is non-linear. Here c is equals to constant. Then third one is variance of cx plus or minus d is equals to c square into variance of x minus variance is translational invariant. Here c and d are constants. Then fourth one is var of x minus k is equals to var of x, where k is equals to constant. And number 5, var of x plus by is equals to s square into var of x plus b square into var of y plus or minus 2a into covariance of xy if not dependent. Here a and b are constants. Then var of x plus by is also equals to s square into var of x plus b square into var of y. Here these are independent. Means you can say that a and b both are independent. Then the next term is covariance. Here covariance of xy is equals to e of xy minus e of x into e of y. Here if independent, then covariance is equals to 0 and e of xy is equals to e of x into e of y. So you can say that x and y both are independent. Then if covariance is equals to 0, then the events are not necessarily independent. So this term you have to remember. Then after properties of covariance, first one is covariance of xy is equals to covariance of yx if both are symmetric. Then second one is covariance of xx is equals to variance of x. Third one is mode of covariance of xy is less than or equal to sigma x into sigma y. Then here next topic is standard distribution function. It is discrete random variable case here. Then first one is binomial distribution. P of r is equals to ncr into p raised to r into q raised to n minus r. Then for binomial distribution, mean is equals to n into p, then variance is equals to npq, and standard deviation is equals to under root n into p into q. These three are the most favorite MCQs for the examination from the binomial distribution. So every aspirant should remember these three equations for binomial distribution. Then second one is Poisson's distribution. Here for this case also you have to remember this equation. Probability of k success is P of k is equals to e raised to minus lambda into lambda raised to k divided by k factorial. Here k is equals to number of success trials, n is equals to number of trials, p is equals to success case probability, lambda is equals to mean of distribution. Then for Poisson distribution, mean is equals to lambda, variance is equals to lambda, and lambda is equals to n into p. So you can say that mean is equals to variance is equals to n into p. So these are the important terms for the binomial and the Poisson distribution. Now let's move towards the next one. Then here the next topic is standard distribution function for continuous random variable case. First one is normal distribution, or you can say that Gaussian distribution. Here f of x is equals to 1 upon under root 2 pi sigma square into e raised to minus x minus mu square by 2 sigma square, where mu and sigma are the mean and standard deviation respectively. Then p of mu minus sigma less than x less than mu plus sigma is equals to 68%. Then after P of mu minus 2 sigma less than x less than mu plus 2 sigma is equals to 95.5%, and P of mu minus 3 sigma less than x less than mu plus 3 sigma is equals to 99.7%. Then for the normal distribution, total area under the curve is unity. So you can say that integration minus infinite to infinite f of x dx is equals to 1. Then second one is the exponential distribution. Here for this function, f of x is equals to lambda into e raised to minus lambda x, where x is greater than or equal to 0. Here lambda is also greater than 0. Then if f of x is equals to 0, then x less than 0. Then second one is uniform distribution function. F of x is equals to 1 upon b minus a for b greater than or equal to f of x greater than or equal to a, and f of x is equal to 0 for all other cases than the first condition. Then fourth one is Cauchy distribution function. Here the equation is f of x is equals to 1 upon pi into 1 plus x square, and the last number 5 Rayleigh distribution function. F of x is equals to x by mu square into e raised to minus x square by 2 mu square. Here these 5 equations are important. Then here the second last topic of this video is mean, median and mode. So here mean, it is the arithmetic mean x bar is equals to sigma xi upon n. Then after median, when the values in a data sample are arranged in descending order or ascending order of the magnitude, the median is the middle term if the number of the sample is odd, and is the mean of two middle terms if the number is even. Then the third one is mode. It is defined as the value in the sample data that occurs most frequently. So for the mean, median and mode, you have to practice some different type of questions. Then here some important points are there. Mean is best measurement due to all observations taken into consideration. Then second one is mode is worst measurement due to only maximum frequency is taken. Then third one is in median 50% of observation is taken. Then sum of the deviation about mean is 0. Then sum of the absolute deviation about median is minimum. Then sum of the square of the deviation about mean is minimum. Then coefficient of variance is equal to sigma by x bar into 100. And correlation coefficient is equals to rho of xy is equals to covariance of xy divided by sigma x into sigma y. Then here -1 less than or equal to rho of xy less than or equal to 1. Then rho of xy is equals to rho of yx. Then mod of rho of xy is equals to 1 when p of x is equals to 0 is equals to 1, or p of x is equals to ay is equals to 1 for same value of a. Then after, if the correlation coefficient is negative, then two events are negatively correlated. Then if the correlation coefficient is 0, then two events are uncorrelated. And third one is if the correlation coefficient is positive, then the two events are positively correlated. Then here, this is the last topic of this video, line of regression. The equation of the line of regression of y on x-axis, y minus y bar is equals to rho into sigma x by sigma y bar into x minus x bar. Then after, the equation of line of regression of x on y is you have to just put the value of x in place of the y. So you can say that you have to substitute the x in place of y. Then after, rho into sigma y by sigma x bar is called the regression coefficient of y on x and is denoted by byx. Then rho into sigma x by sigma y bar is called the regression coefficient of x on y and is denoted by bxy. Then joint probability distribution. If x and y are two random variables, then the joint distribution is defined as fxy of xy is equals to p of x less than or equal to x and y less than or equal to small y. Then here these are some properties which are important for the joint distribution function, or you can say that cumulative distribution function. First one is fxy of minus infinite to minus infinite is equals to 0. Then second one is fxy of infinite to infinite is equals to 1. Then third one is fxy of minus infinite to infinite is equals to 0. Then fourth one is fxy of x to infinite is equals to p of x less than or equal to small x and y less than or equal to infinite, which is equals to fx of x into 1, which is equals to fx of x. Then last one is fxy of infinite to y is equals to fy of y. Then joint probability density function, here it is defined as fxy is equals to del square f of xy by del x into del y. And this property is very useful. Double integration minus infinite to infinite f of xy dx dy is equals to 1. Then here note that x and y are said to be independent random variable if fxy of xy is equals to fx of x into fy of y. So this is all about the second part of the probability and distribution. So if you like this video, please do like and subscribe to our channel for the upcoming videos. In next video, we will discuss about the important formulas of the numerical ability, which will be the part 3 for the mathematics, in which we have prepared total 6 parts. So yes, you can press the bell icon for the upcoming parts of numerical ability. Thank you so much. Hope for the best. Good luck.